Today we are going to create this. We are going to draw anything in midair using our webcam. As you can see in this example, here we draw a line using a pointer in midair. Here we draw line in midair in different colors such as blue, green, red, yellow. This project is known as live webcam drawing using OpenCV. Here we use object tracking method to draw anything in midair using OpenCV. Our program takes the video input from the webcam and track the object we are moving. After identifying the object, it will make contours precisely. Then it will paint all your drawing on the output screen. Hello, my name is Jayant Sarkar. I am full stack web developer, Python programmer and online instructor. And I will guide you through this project. How can we build this project using Python and OpenCV? If you have knowledge about Python programming language, then we can start our journey together. Thank you very much. Before we start our coding, let me introduce you something. This project is part of my Mastering Python OpenCV course on Udemy, and as you can see, it is the new, fresh and bestseller course on Udemy. Till today, it comes with 11.5 hour plus content on it. And it comes with multiple real-world projects. So if you are interested to learn Python OpenCV from the very beginning, I will provide the link in my description. Just check this course on Udemy and you will understand why it has become bestseller. So let's back to the code. Here we are going to use a tracker. We are going to use any color tracker. But for this tutorial, I'm going to use a blue color tracker. You can use a red color also. In this project, you can draw lines in different color. For our project, we are going to use total 4 colors: blue, green, red and yellow. You can use more than that. So let me show you a demonstration how our project is going to work. After hit the run button, as you can see, at first it shows the color detector window. From here, using the slider, you can target any color. And as you know, by default we target the blue color. And we need to wait for some time to start the webcam. Now you can see here it opened total 3 windows: live window, paint window and mask window. And I am going to align these windows side by side. And now I am going to start drawing. Here I already grab a blue marker pointer and I hide it between my finger. And now I am going to start drawing using it. As you can see, our camera track our marker and draw a line. It start drawing with blue color. And you can see the drawing in our live drawing window. Also you can see the same drawing in our white paint window. And in our mask window, you can see the binary mask. And in our mask window, you can notice it only track the blue color marker. It do not track anything else from this footage. And now I am going to hide this marker and start drawing from the different point. And I am going to start drawing from that position. You can notice again it start drawing the path from this position. At that way you can draw different line at different position. Now let me show you how can we change color. How can we change color of this stroke line? For that we need to move our pointer to the color button. At first I am going to move this pointer at green color button. And now it select the green color. And if I start drawing, now you can see it draw the line with green colors. At the same way, if you want to change the color, just you need to put your marker to the next color. For now I am going to select red color. Now it's going to start drawing stroke line with red color. At the same way you can select yellow color. Just you need to hover your pointer above the yellow button. Then you can start drawing using yellow color line. This is how you can change color one by one. And if you want to clear this window, just you need to move your marker above the clear button. As you can see, after move this marker above the clear button, it clear the window. Then again you can start drawing in this canvas. So we successfully build our air drawing project. And if you want to close this project, just you need to press small q. It's going to close the windows. So this is the project we are going to build in this tutorial, and we are going to start it from the next video. So thanks for watching this video. Stay tuned. So finally, we are in my Visual Studio code editor. So as you can see in my current working directory, we already create a Python file main.py. So let's start with import the library. At first I want to import numpy library. Import numpy as np. It is used for numerical operation, including creating matrix and arrays. And then I'm going to import cv2, our main module. Import cv2. And here I'm going to import another important module, which is known as deck. And we need to import it from the collection module. So I'm going to type from collection, I want to import deck module, DEQUE. It is a double enable deck from collection module. It is used to store points for drawing efficiently. And next we need to create the trackbars for the color adjustment. We already learned about trackbar in our previous projects, so I'm not going to explain this topic in details. And as you know, to create the trackbars, we need a helper function. We need a callback function. So before I create the trackbar, I'm going to declare a function, def, and our function name is setWidth. Then inside the round braces, I'm going to pass x as parameter. Then inside this function, just I'm going to print a blank statement, print. It is a placeholder function for the trackbar callback. It is called whenever the trackbar value changes. Now we can create the trackbars for the color adjustment because we already created a default function. So here, at first we need to provide a trackbar name. For that I'm going to type cv2.nameWindow. Inside the round braces, I want to provide a trackbar name, and our trackbar name is color detector. After assigning the name, we need to create total 6 trackbars. First one is for upper hue, then we are going to create for upper saturation and upper value. Then other 3 are lower hue, lower saturation and lower value. To create our first trackbar, I'm going to type cv2.createTrackbar. This one. Then inside the round braces, inside the double quotes, first we need to provide the trackbar name, and this trackbar name is upper hue. Next, we need to provide the window name, in which window I want to show the trackbar, and our window name is color detector. So I copy the window name and put it inside the double quotes. Then here we need to pass the value, the initial position of the trackbar slider when it first deployed. In this case, I want to start it from 153. Next, we need to pass count value. It's going to set the maximum value of trackbar slider, and here I'm going to pass 180. Now it set slider range from 0 to 180. After that, we need to provide the default function. As you can see, our default function name is setValue. So I copy the function name and I'm going to put it here. For upper hue, we set value 153. Then we are going to create upper saturation. So I duplicate this line. At first I'm going to change hue value, upper hue to upper saturation. Upper saturation, first I'm going to change the value and I'm going to make it 255. Then I'm going to change the range value, which is also 255. When we open the trackbar, it's going to set the default value to 255. It's going to set the default value 255 for upper saturation. Next, I'm going to create upper value. So I duplicate this line and here I'm going to set upper value. For upper value also I'm going to use value 255 and count value 255. After create the upper track bars, we need to create 3 lower track bars. So I duplicate this whole section and I'm going to change the values. This is upper, this is lower hue. For lower hue, I'm going to set value 64. Then I'm going to set and also I'm going to set range value 180, and our range value remains same. Then for lower saturation, I'm going to set value 72, and our range is remains same. And for the lower value, I'm going to set value 49, and its range remains same. By default, this color range going to detect the blue color. This trackbar, otherwise we can call it slider, created for adjusting HSV values. HSV stands for hue, saturation and value. We create this HSV adjusting threshold for detecting the marker color. And by default here we set blue color. So we don't need to adjust too much when we open our program. So this is the first part of this tutorial. Basically in this part we import the libraries and create the trackbars for color adjustment. At the next part of this tutorial we are going to create the color points and also we are going to create the drawing setup. So thanks for watching this video. See you in the next part. Good to see you back guys. This is the second part of this tutorial, and in this part we are going to conduct coloring point and drawing setup. At first we need to create color buffers. Color buffer is a list of decks to store drawing points for each color, such as blue, green, red, yellow. Yes, we are going to use total 4 colors to draw in our canvas: blue, green, red and yellow. So let's create the color buffers. So we need to create a deck. We need to create multiple decks. So first I'm going to create a deck for blue points, blue color points, B points. Blue points equal to, inside the square braces, I'm going to use a method from the deck module. We already import a module called deck, so we are going to use it. So I'm going to type DE deck QUE. Inside the round braces, here I'm going to use a function called max length, maximum length, MAXLEN, and I'm going to set it 1024. Then I duplicate this line, and next I'm going to create points for green color, G points. Also I'm going to create deck for red points, R points. At last I'm going to create deck for yellow color. So I duplicate this line, and this is for Y points. It is a list of deck to storing the drawing points for blue, green, red and yellow marker. Each deck has maximum size of 1024 to limit memory usage. This array stores the points. I want to show the coordinates, which is drawn with specific color. In our case, we use blue color, green color, red color and yellow color. And next we need to index and mark point for specific color. So for that I'm going to use variable. For blue color I'm going to use blue underscore index. Blue underscore index equal to 0. Then I duplicate this line. Next I'm going to create index for green color. Then I'm going to create index for red color. And at last I'm going to create index for yellow color. Yellow index. These variables act as pointer to the current deck in the respective colors array. When a new stroke begins for a specific color, then a new deck will be added to the corresponding array. Suppose I start drawing at that point and I draw this line. After draw this line, I hide this marker. Now if I start drawing at that position, it's going to create a new deck. And according to the color we select, we are going to store this new deck coordinates in these points. Suppose we use blue color, then we are going to save this new deck at the blue points. Don't worry, we are going to explain it later after complete the project. with practical demonstration, how it's going to work. Next, we need to define the kernel size for morphological operation. So here I will type a variable name kernel. Kernel equal to np dot once. Here I'm going to create a kernel size using numpy array. Inside the round braces, I'm going to pass 5 by 5 pixel kernel size, and next we need to pass d type, and here I'm going to type np dot ui nt8. This is the doc type. This kernel is used in morphological operation like dilation and process the enlarges bright region in a binary image. First we create a 5 by 5 matrix field with ones, and then we define the doc type. np.uint8 ensure it contained unsigned 8-bit integers. I want to say value between 0 to 255. Basically, it is enhance the detection of color point in an image, ensuring small gaps in a drawn line or detected color are filled. So this is it for this tutorial. At the next tutorial, we are going to draw paint window canvas. We are going to create a blank canvas where we are going to draw. Then we are going to create buttons for color. Also, we are going to create extra button for TRA. So stay tuned for the next part. Hello guys, good to see you back. This is the third part of this tutorial, and in this part we are going to paint the window canvas. Here we are going to create the canvas and the buttons. So at first I am going to define the colors. So I am going to create a variable colors. And it is an array, and inside this array we are going to create a tuple. So inside this array, inside the round braces, I am going to type the first color code. I am going to set the blue color. So for blue, I am going to type 255, 0, 0. Then after comma, inside the round braces, we need to set the green color. So I'm going to type 0, 255, 0. And next I'm going to set the red color. Then inside the round braces, 0, 0, 255. Then after comma, inside the round braces, I'm going to set another color which is yellow. And for yellow, I'm going to type 0, 255, 255. So here I'm going to use total 4 color as a marker. Blue, green, red and yellow. Then I'm going to create a color index. So I'm going to type color index. For now, I'm going to assign 0. After color and index setup, we need to set up the canvas. For that, we need to use numpy. So first I'm going to declare a variable, and our variable name is paint window. Paint window equal to draw the canvas, I'm going to use np.zeros method. Inside the round braces, first we need to define the dimension of this canvas, and I'm going to make it 471 by 636, and I'm going to use total 3 color channel. So I'm going to pass 3. After that, I want white color canvas. So I'm going to add plus 255. It's going to generate a white color canvas. It's add 255 to all pixel value, so it's going to make it white. By default, np.zeros create a black image. And now we need to create the UI components. We need to create the buttons, such as clear button, other color buttons. Also, we need to put text on this button. For that, we are going to use rectangles to draw the button. And I'm going to draw this rectangle on this blank window. So I'm going to type paint window equal to cv2.rectangle method, rectangle. And inside the round braces, first we need to define in which image I want to draw the rectangle. In our case, paint window. Then we need to define the first point, First, we need to define the top left corner. So here I'm going to pass inside the round braces 40, comma 1. Then we need to define bottom right corner of this rectangle. Inside the round braces, I'm going to pass 140, comma 65. Then we need to define the color. For now, I'm going to use black color for the clear button. So I'm going to make it black. So inside the round braces, I'm going to pass 0, 0, 0. Then we need to provide the thickness. And for thickness, I'm going to use 2. At the same way, I'm going to create other buttons for the other colors. This is for clear button. So I duplicate this line, and this time I'm going to change the points. After duplicate this line, first I'm going to change the top left corner value point. Now it starts from 160 and it's end with 1. This is the x-axis value and this is the y-axis value. And also we need to provide the bottom right corner value. Now it starts from 255. And here I am going to use our first color from this colors variable, blue color. To select the blue color, here we need to type colors, and then I want to call the first index. So inside the square braces, I'm going to pass 0. And as you know, at the first index, we assign the blue color. And I want to fill this rectangle with the color. So as a thickness, I'm going to pass -1. It's going to fill the rectangle with the color. Then I duplicate this line, and this time I want to select the second color. So I pass index value 1. Also, we need to change the position of this rectangle. So here I'm going to type 275 by 1. For bottom right value, I'm going to pass 370. This is for green color button. And then we need to create for red color button. So I duplicate this line again. And first I'm going to change the index number 2. And also we need to change the position of starting point of this rectangle. Here I'm going to pass 390. And the bottom right corner value is 485. Then we need to create button for yellow color. So I duplicate it again. And I'm going to change the index number, make it 3. Also we need to define the position. I want to start it from 505 pixel and our bottom right value is 600. And I'm going to satisfy. And now I'm going to put text on this clear button because for clear button here we use black color. So I want to put a text on it. For that, here we need to type cv2.putText method. Put text. Then inside the round braces, first we need to define in which window I want to put the text, which is paint window. This one. Then we need to pass the text. What text we want to pass? And I want to type clear. Then we need to define the origin point of this text. And inside the round braces, I'm going to pass 49, 33. This is the origin point of this text. And next, we need to define the font face, which font I want to use. For the font face, I'm going to use cv2.fontharsh _ fontharshi simplex. This one. And next, we need to define the font scale, and I'm going to use 0.5. After defining the font size, we need to define the font color, and for the font color, I'm going to use that color. So I'm going to pass 0, 0, 0. Then we need to provide the thickness, and I'm going to use 2. And at last, we need to provide the line type. For line type, I'm going to type cv2.line _AA, this one. Next, I'm going to create a window to display the canvas. For that, I'm going to type cv2.nameWindow method, name window. Then inside the round braces, at first we need to provide the window name, and in our case I'm going to type paint. And also we need to define the flags to control the properties of this window. So here I'm going to pass cv2 dot window auto size, this one. This window auto size ensures that the window automatically adjusts its size to fit the display content. It may be video or image. So this is it for this part. At the next part we are going to start the frame processing using for loop, and we are going to extract frame from our webcam. So thanks for watching this video. Stay tuned for the next tutorial. So good to see you back. This is the another part of this project, and we are going to start this part with capturing the video frame. So first I'm going to comment out this line. We don't need this paint window, so I'm going to comment out it for now. And then I'm going to create a variable, and our variable name is cap equal to cv2 dot video capture, this one. And then inside the round braces I'm going to pass the source, and we want to start the default cam, so I'm going to pass 0. Here we initialize the webcam for capturing the live video. Next we need to run an infinite loop for video processing. For that, here I'm going to use while loop, while true. Then inside this while loop I'm going to use a method. I'm going to use read method. So here I have to type cap dot read. This method going to read all the frame from this cap variable. And as you know, this method going to return total 2 results. First it going to return a boolean value, then it going to return the actual image frame, and we need to store both the values in a variable. So for the boolean value, here I'm going to use a variable called success, and for the image I'm going to use frame variable equal to cap.read method. Now after read the frame, I'm going to flip the frame. I want to flip the frame horizontally because I want to act this window as a mirror. For that, so here I'm going to type frame equal to cv2 dot flip method. Then inside the round braces, first we need to pass the source file. First we need to pass the source, image source, and our image source name is frame. And also we need to pass the flip code, and as a flip code I'm going to pass 1. This value going to flip the frame horizontally. Next I'm going to convert this frame into HSV color space. For that, I'm going to declare another variable HSV equal to cv2 dot cvt color. Inside the round braces, as a source I'm going to pass the frame, and then I'm going to convert this BGR image into HSV color. So I'm going to type cv2 dot color underscore, and I want to convert it BGR to HSV. Here we convert this frame into HSV color space for easier color segmentation. And as you know, HSV stands for hue, saturation and value. Next we need to grab the HSV threshold value. We need to retrieve the upper and lower threshold value from these track bars. For that we need to use a method, and our method name is get trackbar pause. So at first I want to retrieve upper hue, so I'm going to type hue stands for upper underscore hue. Upper hue equal to cv2 dot get trackbar pause, this function. Then inside the round braces, inside the double quotes, here we need to pass, at first we need to pass the trackbar name, from which trackbar I want to retrieve the value. And our trackbar name is upper hue, so I'm going to copy this trackbar name upper hue, and I'm going to paste it inside the double quotation. Then we need to pass the window name, and as you can see here we declare the window name. and our window name is color detectors. So I copy the window name and I'm going to put it inside the double quotes. At the same way, we need to grab the upper saturation value. For that, I'm going to duplicate this line and at first I'm going to change the variable name. It is for upper saturation. Also, we need to change the trackbar name. So I'm going to copy the value upper saturation and I'm going to paste it here. Then I duplicate this line and also we need to use the same window name, which is color detector. And then we need to create variable for upper hue, upper value, and for upper value I'm going to copy this trackbar name, upper value. So here we retrieve upper hue, upper saturation and upper value. At the same way, we need to retrieve lower hue, lower saturation and lower value. So I'm going to duplicate this section and I'm going to replace the variable names. This is for lower hue, and for the lower hue, I'm going to use this trackbar name, lower hue. And for lower saturation, first I'm going to change the variable name, lower saturation, and here we need to type just lower saturation. And for lower value, L value equal to, and just we need to type lower here, lower value. Here we retrieve the current position of trackbars. I want to say these sliders. And as you know, these trackbars allow dynamic adjustment of HSV threshold for color detection in real time. We already done it in our previous projects. And now we need to define the upper and lower HSV color range. For that, I'm going to create a variable called upper underscore HSV. Upper HSV equal to np dot array. Inside the round braces, I'm going to use square braces, and here I'm going to pass all the upper variables. Upper hue, first I'm going to pass upper hue, then I'm going to pass upper saturation, and next I'm going to pass upper value. At the same way, we need to declare another array. We need to create another array for lower HSV value. So here I'm going to duplicate this line and here I'm going to type lower HSV and I'm going to pass L hue, lower hue. So I'm going to replace U with L, lower saturation and lower value. Now after create the upper and lower HSV, we need to create the rectangle buttons to our live frame. For that, I'm going to use this same method, the rectangle method, to create the rectangle at the same position. So I copy all the rectangles from the paint window and I'm going to put it below the lower HSV, and we need to move it inside the indentation level. It is important because we are working on Python. That's nice. Now this time we need to create this rectangle in the light frame, this frame. Here we create the rectangle button at the white window, this paint window, but this time we need to create it inside the light frame. For that, we need to replace this paint window variable with the frame variable. So I copy the variable name frame and I'm going to replace paint window with frame variable. So one by one, I'm going to replace all the frame name, all the variable name, frame. Don't worry, I fast forward this process. And also I'm going to fill this clear rectangle with black color. So here I'm going to pass -1. And I'm going to set this file. After set this file, I'm going to put the text on this clear button. For that, I'm going to copy the same line, put text. So I copy this line and I'm going to paste it after the rectangle. Here we don't need to change anything. Here just we need to change the frame name. And we need to put the text at this frame variable, not the paint window. So I'm going to copy. So I'm going to replace paint window with frame variable. Frame. And I'm going to save this file. And now I'm going to run this code in my terminal. But before I run this code in my terminal, here I'm going to set a if condition. Otherwise, it's not going to break the loop and throw an error. So at first I'm going to set a condition to exit the loop. So here I'm going to type if cv2.wait key inside the round braces, I'm going to set 1 millisecond and $sign 0xff equal to I'm going to run the ord method ord inside the round braces. If I press small q, then I want to break the loop. So inside the if condition, I want to break the loop. Break. Also, we need to release the capture. So outside the while loop, here I'm going to type cap.release method. Cap.release. This method going to release our webcam. Also, I'm going to destroy all the windows. cv2.destroy all windows. This one. And then I want to display total 2 frames. At first I want to display the white window, which is paint window frame. So here I'm going to run a method called cv2.imshow method. And inside the round braces, here I'm going to pass window name, and our window name is white window. And also we need to pass the frame source. And as you can see, we are going to use this frame, paint window, this blank frame. So I copy the variable name and I'm going to paste it here. Then I'm going to display another frame. So I duplicate this line, and this time I want to display this main frame, the light frame. So here I'm going to type cam. This is light cam. And also I'm going to paste the variable, which is frame. And I'm going to set this file. Basically, I'm going to run this code for checking purpose. Does he place the rectangles where we want to place? So let's check the code. After run this code, as you can see, first it's going to show the trackbar, the color trackbar, where you can see the slider. And after wait for some time, it's going to open our camera. So we need to wait for some time to start the camera. So as you can see, here you can see a white window. And we have total 5 buttons. 4 color button and 1 clear button. At the same way, in our live window, here you can see we have total 5 buttons. 4 color button and 1 clear button. But the problem is the clear text is not visible at the live window because here we use same background color, black. That's why the text match with the background color. And to make it visible, we need to make it white colored. So I'm going to close all the windows, and here I'm going to type 255 for blue. For green also I'm going to pass 255, and for red also I'm going to pass 255. Now if I run this code, it's going to return the white text at the live window. And as you know, by default in our sliders, here we set blue color. It's going to detect the blue color. Also you can change if you change the slider values. So this is it for this tutorial. At the next part of this tutorial, we are going to work on masking. Also we are going to detect the contours. So thanks for watching this video. Stay tuned for our next part. Good to see you back, guys. Once again I am back with another video related to this project. And in this part, we are going to identifying the pointer by making a mask. So at first, I am going to comment out both the lines. I don't need these lines for now. And then, I'm going to create mask. After create the mask, we need to refine the mask over and over again using different methods. So at first I'm going to create a mask. So I'm going to declare a variable mask mask equal to, I'm going to use inRange method cv2 dot inRange. Then inside the round braces, at first we need to provide the source file. As a source, I'm going to pass the HSV image, HSV. Here I pass this HSV frame, this one. After that, we need to pass lower HSV. So for lower HSV, as you can see, here we create a variable, lower HSV. It's an array. So I'm going to pass this array. And then we need to pass upper HSV. Upper HSV. Basically, inRange function going to isolate the desired color range. And use this function, we can create a binary mask. This mask is a binary mask where white pixel represent the areas of the original image that match the desired color range. Suppose we select blue color, and this mask going to detect the blue color and make this portion white. And after create the mask using inRange function, we need to remove noise by shrinking the white areas. To removing the noise by shrinking white areas, we need to use a method called erode. So here I'm going to type mask equal to, and in this mask I'm going to apply cv2 dot erode method. Erode. Then inside the round braces, at first we need to provide the source. And as source, I'm going to provide the mask variable, mask. After that, we need to pass the kernel size. And for kernel, I'm going to pass this variable, kernel. Here I create 5 by 5 kernel. So I copy this variable name kernel and I'm going to pass it here. Then we need to define the iteration. And for iteration, I want one iteration. At first, here we pass the binary mask, which is opted from the previous step. And then we pass the kernel. This is a structured element, which is used for erosion. And then we pass iteration. And here we pass 1. It is defined number of times the erosion operation is applied. Basically, this method going to reduce the size of white region by removing boundary pixels. After that, we need to remove all small noise. For that, we are going to use a method called morphology ex. So here, again I'm going to type mask equal to cv2 dot morphology ex, and then inside the round braces, at first I'm going to provide the binary mask, and then we need to provide the operation, a morphological operation. For that I'm going to type cv2 dot morph open, this one. And next we need to define the kernel size, and for the kernel size I'm going to use the same variable kernel. Basically here we step by step filtering the mask, and this method going to remove all the small noise. And next we need to expand and refine the white area to restore the shape. For that we need to use another method, I want to say another filter, which is dilate. So again I'm going to type mask equal to cv2 dot dilate method. Then inside the round braces, at first we need to pass the binary mask. So I'm going to type mask, comma, then we need to provide the kernel size, which is kernel. And then we need to provide the iteration. And for iteration, I'm going to pass 1. This sequence is commonly used in tasks like object detection. Also, it's work in color-based segmentation. Or we can use it for contour detection. After applying all the methods, it's going to refine our marker object. Next, we need to find the contours for the pointer after identifying it. But we are not going to do this step in this video. We are going to do it to the next tutorial. And now I am going to display this mask window using IamShow method. For that, here I am going to type cv2.imshow, and inside the IamShow method, first we need to provide a window name. For window name, I am going to use mask. Also, as a variable, I am going to pass the mask variable. Then I am going to set this file. After set this file, I am going to run this code in my terminal, and I am going to wait for some time and see is it work properly or not. As you can see, it open a black mask window, and you can see nothing in this window. But in my hand I have a blue pointer, blue color pointer, and if I move this pointer in front of my camera, now you can see it identify this blue pointer. Now you can see only blue pointer. When I move my hand, also it moved the pointer. It's working. So we successfully identify the pointer. After identify the pointer, we need to identify the contour. But I'm not going to do this in this tutorial. I'm going to do it at the next tutorial. So thanks for watching this video. Stay tuned. Hello guys, good to see you back. Once again, I am back with another tutorial related to this project. And in this tutorial, we are going to find the contour for the pointer. At first, I'm going to remove both this line. I don't need it. Then, inside this while loop, I'm going to detect the contours. We need to find the contour in this binary mask. Basically, contours are curve joining all continuous points along the boundary of object having the same intensity. Now, to find the contours, we need to use find contour method. So at first, I'm going to declare total 2 variables. For contour, I'm going to type cnts. With that, I'm going to declare another variable called z equal to, and I'm going to use our method find contours. So I'm going to type cv2 dot find contours. Inside the round braces, first I'm going to type mask dot copy. I'm going to use the copy version of this mask. Then, as second parameter, we need to pass the mode. And here I'm going to type cv2 dot retr underscore external. This one, comma, and also we need to pass the method. And for method, I'm going to type cv2 dot chain approx simple. This one. This method going to return list of contours which is found on this image, the mask image. And the second variable is for second output, which is hatchery. It is ignored as it is not used here. In our first parameter, we pass the copy version of this binary mask image. And second, we pass the mode. This mode retrieves only the external outer contours and ignoring any instead ones. And at last, we pass contour approximation method that compress horizontal, vertical and diagonal segment to keep only their endpoints. It's going to reducing memory usage. And as I told you, this method going to return a list of contours. Next, we need to process the largest contour. But before, I am going to comment out this line, otherwise we can remove this line. We don't need this. But before I process, first I'm going to declare a variable. And our variable name is center. Center equal to, for now, I'm going to make it none. This variable initialize with none. It will store the coordinates of the center of the largest contour if 1 is found. Next, we need to process the largest contour using if condition. Here I'm going to type if, and I'm going to use len function. Len, inside the len function, I'm going to pass the contours, CNTS. If contours greater than 0, then inside this if condition, now we need to shorten the contours to find the biggest contours. To sort the contours, I'm going to type CNT equal to, I'm going to use a method called sorted. Sorted inside the round braces, first we need to pass the iterable, and we are going to iterate this variable, contours, CNTX. Next, we need to pass the key. Key equal to, I'm going to pass CV2 dot contour area. Contour area, this one, comma, and I'm going to type reverse equal to true. And to select the largest contour from this list, we need to pass the index number. So inside the square braces, I'm going to pass 0. Now let me explain this sorted method. Here we sorted the contour based on their area in descending order. That's why here we type reverse true. Next, we need to find the smallest circle that can completely enclose the selected contour. For that, I'm going to type inside the round braces, again I'm going to use round braces, then x coordinate, comma, y coordinate, and outside the round braces I'm going to pass comma, I'm going to pass radius equal to get the radius of the enclosing circle around the contour, we need to use a method, and our method name is mini enclosing circle. So here I'm going to type CV2 dot mini enclosing circle, this one. Then inside the round braces, we need to provide the contour, the exact contour, which we find from this list. So I'm going to type CNT, and this method returns x-axis coordinates, y-axis coordinates, also it returns radius. Then using this x-axis, y-axis and the radius, we are going to draw a circle. We are going to draw the circle around the contour. For that, I'm going to use circle method. So I'm going to type CV2 dot circle. Then inside the round braces, first we need to provide the image, in which image I want to draw the circle, and here I have to pass the exact frame, this frame. So I'm going to type FRAME, frame. Next, we need to pass the center point. So inside the round braces, here I'm going to type x, comma, y. But the problem is, we need to convert these coordinates into integer. This function returns the coordinates in a string format, so we need to convert it into a integer. So I'm going to use int function. int inside the round braces, I'm going to pass the x-axis. At the same way, int inside the round braces, I'm going to pass the y-axis. Next, we need to pass the radius. For radius, again I'm going to use int function, int method int. Then inside the round braces, I'm going to pass radius. After provide the radius, also we need to provide color. For color, I'm going to use 0, 255, 255. It's a yellow color. And then we need to pass thickness of this radius, and as a thickness I'm going to pass 2. And now after draw this circle, inside the contour, we need to detect the center. We need to detect the center point. To calculating the center of the detected contours, first I'm going to type a variable called m equal to, and I'm going to use a method CV2 dot moments. and inside the round braces I'm going to pass the contour, CNT. Using this method, we calculate special moment of the contour, which are scalar quantities used to derive the contour's properties. Now, using this special moment, we need to calculate the center of this circle. And for that, we need to use a formula. But before I calculate the center, first we need to understand the moment method. So as you can see, here I type two single line comment. This moment method return two order. This is first order moment. Here it contains M10 point and M01 point, and this one is 0th order moment, area of the contour, and here it return M00 point. So if I divide M010 and M01 with M00, it's going to return x-axis coordinates and y-axis coordinates of this circle center. For that, we need to use a method. For that, I'm going to create a variable to calculate the center point. So I'm going to type center. Center equal to, inside the round braces, at first I'm going to extract the x coordinate. So I'm going to use int method. Int, integer, inside the round braces, at first I'm going to divide m inside the square braces, inside the single quotes, m10, and I want to divide it, so I use division sign with m inside the square braces. This time I want to pass inside the single quotes M00, comma. Now we need to extract the y coordinate. This is going to return the x coordinate, and also we need y coordinate. So the same way, I'm going to type int inside the round braces. Here I'm going to pass m inside the square braces. At first I'm going to pass M01, and I want to divide this m inside the square braces, inside the double quotes, M00. This is going to return the y coordinates, and it's going to store it in the center variable. Center equal to this calculation. Int convert the calculated coordinates into integers, because we need this value as a pixel position. Basically, this code detects the largest contour in a binary image, in our case mask, from the mask image, and draw a circle around it. Also, we compute the center using a special movements. It is commonly used in object tracking applications. So this is it for this tutorial. At the next part of this tutorial, we are going to handle the button. We are going to handle the button clicks. So thanks for watching this video. Stay tuned for the next part of this tutorial. Good to see you back, guys. Once again, I am back with another video related to this project. And in this section, we are going to handle the button clicks. As you know, we create different buttons such as clear button, red color button, yellow color button, green color button, and blue color button. Now we need to handle the button clicks. So when I hover my marker above the button, I want to activate the button program. Suppose if I hover my marker above the clear button, I want to clear all the drawings. At the same way, if I hover my marker above the yellow button, then I activate the yellow marker. Then it's going to draw the shapes into yellow color. So let's start with the if condition. So here I'm going to type if center inside the square braces, I'm going to pass index number 1 less than, otherwise equal to, less than equal to 65. Then inside this if condition, I'm going to use another if condition. But before I'm going to explain this line, what is the meaning of this condition? This is going to check if the center of the dedicated object is within the top region of the screen, such as y coordinates is less than or equal 65. then this area is reserved for clickable button. Then inside the if condition, first we are going to handle the clear button. So I'm going to type if 40 less than equal to center inside the round braces index number 0 less than equal to 140, then inside this if condition, basically this condition going to checks if the x coordinates of the center lies within the range between 40 and 140 corresponding to the clear button's position. If true, the clear action is triggered. Then we need to clear all points for blue color, green color, red color and yellow color by resetting their corresponding list of deck object. And as you know, each deck holds point for drawing. So one by one, I am going to clear all the points, all the color points. As you know, here we declare our deck points. We create deck objects. B points, G points, R points and yellow points. These points are for blue color, green color, red color and yellow color. So I'm going to copy the whole section. I'm going to use this same code and I'm going to paste it inside this if condition here. And I'm going to place it inside the indentation label. And for this deck, I'm going to set the memory usage. And for now, I'm going to set memory usage 512. So I'm going to replace all the values with 512. These deck points storing the drawing points for blue, green, red and yellow markers. And here we set the limit of maximum size, and each deck has maximum size of 512 to limit memory usage. And also we need to reset all the color indexes for each color to 0. So here I'm going to copy this section, this color indexes, blue color index, green color index and red color index and yellow color index, and I'm going to paste it here. Also we need to move it inside the indentation level. Now to clear the drawing area of the paint window, we need to remove all the stroke colors from this paint window. We need to make all the pixels white. For that, I'm going to type paint window inside the square braces. Here we need to clear the drawing area of the paint window by setting all pixels below the row of 67 to white. So at first we need to refer to all rows starting from row number 67. So here I'm going to type 67 then semicolon. It's mean from row number 67 to end. I want to say from row number 67 to bottom of the image. Then we need to refer all the columns, entire width of the image range. For that, I am going to type comma, then colon. Next, we need to refer all the channels. So again, I'm going to type comma, and also need to type the colon to select all the color channels. So this selects the entire drawable area of the image starting from 67th row. And then I'm going to assign a value to the selected part, and I want to assign 255. Here we assign the value selected part of this array, and 255 represent the maximum intensity for each channel, for each color channel. Basically, it's going to return white pixel. So it's going to activate the clear button and clear the window. Then one by one, I am going to use these coordinates and activate this particular rectangles. So first, I am going to work for blue color. So here I am going to type else if inside the elif condition 160 less than equal to center. Inside the square braces, I'm going to pass 0 index. With that, less than equal to 255. Then inside this elif condition, here I'm going to type color index equal to, and I want to select the first index. And as you know, in our color index, we say total 4 color, and in our first color is blue color. So I'm going to use 0 index. This is for blue color. So here I'm going to type a comment hashtag it is for blue. Then I duplicate this section, and this time I'm going to set the coordinates between. For green color, I'm going to type 275 by, and our area is 370. Then I'm going to change the color index value. I'm going to make it 1. Then again, I'm going to duplicate this section, and this time our pixel range between 390 between 485. And I'm going to use, this time I'm going to use color index 2. This is for green color, so I'm going to change the comment green. And this one is for red color. Then again I'm going to duplicate this section, and this time I'm going to change the coordinates. Now it starts from 505 pixel and it's go up to 600 pixel. And this time I'm going to use our third color index 3. So if we move our marker pointer at that positions, at that coordinates, then it's going to activate this color option. If we move our marker between 160 by 255, then it's going to turn on the blue color. At the same way, it's going to turn on the green, red, and last one is yellow color. And now we need to handle the drawing if the user is not in the button area. So in the else part, else, inside the else condition, this else part execute when the center is not top region. I want to say the top region of the screen. If our condition do not match this if condition, then it's going to jump into the else part. So if our condition is greater than 65, then it's going to jump into the else part. And in this else part, we are going to handle the corresponding color deck. We are going to append the center point to the corresponding color deck. So one by one, I'm going to handle all the color index. And we need to append the color points to the color index. And as you know, these are all color index. So here I'm going to type if color index equal to 0. As you know, 0 stands for blue color. 0 index stands for blue color. Then inside this if condition, I'm going to type b points inside the square braces. Here I'm going to pass blue index, and I want to append the coordinates. So here I'm going to type dot append left. Then inside the round braces, I'm going to pass the center coordinates. So here I'm going to pass center. As you know, B point is a list of decks that store the points. I want to say the coordinates, which is used for drawing with a blue color. And each deck represents the single stroke of blue drawing. And blue index is an integer that tracks the current stroke. If we draw any stroke with blue color, then it's going to track it. It is used to access the correct deck in blue point to store new points for the current stroke. And the append left method adds the points front of the current deck in blue points. And here center represents the coordinates of the detected points. Basically, I want to say when the user draws in blue, the program continuously detects the position of this pointer and adds to the deck for the current blue stroke. And using append left function ensure the points are stored in reverse order, which may be useful for efficient reading and processing. At the same way, we need to handle all the colors. So here I'm going to type elif color index equal to, this time I'm going to pass 1. Then here I'm going to type G points. This is for green, so I'm going to type G points. Inside the square braces, here I'm going to pass green index. And At the same way, I want to append left. Inside the round braces, I'm going to pass the center. Then I duplicate this section, and this time I'm going to append color index. I'm going to access color index 2, which represent red color. And this time I'm going to use R points. Also, I'm going to change the index name. Without using green index, I'm going to use red index. And again, I'm going to duplicate this section, and we need to handle the yellow color. So here I'm going to pass color index 3, and I'm going to replace R points with yellow points. Also, we need to replace the index, yellow index. So this is how we can draw shapes in different color using these conditions. And now we need to handle this scenario where nothing is detected. I want to say, now we need to append the next deck when nothing is detected to avoid the missing out. So here I'm going to type else condition. Else. Then inside the else condition, here we need to handle when the application detects that the user has stopped drawing. Then it's need to prepare for the next row. Create a new deck. To create a new deck, also we need to increment the blue index. So one by one, I am going to create a new deck for every color. Also, I am going to increment the indexes. So inside the else condition, first I am going to handle the blue color. So I'm going to type b points. Then I'm going to use append method dot append, and I'm going to append a new deck. Then inside the round braces, I'm going to type deck, and inside the round braces, also we need to set the maximum length, and here I'm going to set maximum length 512, and also we need to increment the index. So I'm going to type blue index plus equal to, and every time I'm going to increment with one value, 1. At the same way, we need to handle other colors. This is for G points, green colors, and here I'm going to replace the index name, green index. At the same way, I'm going to handle the red index, R points, and also I'm going to replace the index, R index. Next, I'm going to handle the yellow index. So I duplicate this section and replace R point with yellow points. And after add a new deck, I'm going to increment the yellow index. Basically at that section, after handle the click buttons, here we draw on canvas. First we handle the click buttons, then we draw on canvas. Then we handle the scenario where nothing is drawing, nothing is detected. And to handle it, we create a new deck for each color and increment new index for each color stroke. So this is it for this tutorial. At the next part of this tutorial, we are going to draw lines for all colors on the canvas and the frame. So this is it for this tutorial. Thanks for watching this video. Stay tuned for our next tutorial. Good to see you back, guys. Once again, I am back with another video related to this project. And in this video, we are going to draw lines for all the colors on the canvas and the frame and the light frame. At first, I am going to create a list, and our list variable name is points. Points equal to, and inside the square braces, I am going to pass the points. And one by one, I am going to put these points in this list. First, I am going to pass B points, blue points. Then I am going to pass G points, which is green points. Next, I am going to pass R points. And at last, I am going to pass Y points, yellow. These are all different lists inside this point list, and all the lists hold coordinates grouped by stroke. And now we need to run a loop to iterate all the points one by one. For that, I'm going to run a for loop. So here I'm going to type for I in, and I'm going to use range function, range. Then inside the range function, I'm going to use len function, len. Inside the round braces, I'm going to pass points. Then inside this for loop, basically this loop iterate over the index of points that represent different color, such as blue, green, red and yellow. And now inside this for loop, we need to iterate stroke from these points. For that, again I'm going to run another for loop. For j in range, inside the range function, here I'm going to type length. Then inside the round braces, I'm going to type points. And inside the square braces, I'm going to pass I. Then inside this for loop, now inside this for loop, we need to iterate through the points in the current stroke. For that, I'm going to type another for loop. For k in range, inside the round braces, at first I'm going to pass index number. As a first parameter, I'm going to pass 1. Then, and to access the current stroke, here I'm going to type len function len, and inside the round braces, I'm going to access points. Inside the square braces, first I'm going to pass I. Then I'm going to pass j. Then inside this for loop, but before, let me explain this for loop. Here, k start with 1 because the code contains each point to the previous point. If k start at 0, there would be no previous point. Then inside this for loop, we need to check a condition. If the current point or the previous point is none, then we need to continue this process. For that, here I'm type if points inside the square braces our current point is I, then inside the square braces j, and again inside the square braces I want to access k minus 1 is none, or here we use OR operator or, and our previous point is none, so here I'm going to type points inside the square braces I, then inside the square braces j, and at last inside the square braces I'm going to pass k is none. Then inside this if condition I'm going to type continue. Then I'm going to continue this loop. It's mean if none is found, it skip to the next iteration. This prevents error and ensure that the program does not attempt to draw a line involving invalid points. Then I'm going to draw a line in a live video frame. For that, we are going to use line method from OpenCV. So here I'm going to type cv2.line method, line, and inside the round braces, first we need to pass the source image, in which image I want to draw the line, and I'm going to pass the frame image, frame, because we are going to draw the line in a live footage, comma, then we need to pass the points, the starting points. And for the starting points, I'm going to use this point. Then we need to pass the end points, and for end points, I'm going to pass this point. So copy the point values, and I'm going to put it here. At last, we need to pass the color. What color we are going to use? And we need to grab the color value according to the index number. So here I'm going to type colors variable, colors, and inside the square braces, I'm going to pass I, the iteration, and then we need to pass the thickness, and for thickness I'm going to pass 2 pixel thickness, and at the same way we are going to draw line in the paint window. So I duplicate this line and just I'm going to replace the window name, the source name, paint window, this one, and I'm going to set this file. Now we are almost done. Now just we need to show the window using image show functions. So here I'm going to type CV2. We need to move it inside the indentation level. CV2 dot I am show method. I am show. And at first I want to show our live frame. And first we need to provide a window name for this frame, which is live drawing. And then we need to pass the frame name, which frame I want to show. And our window name is frame. Next, I'm going to duplicate this line, and this time I want to show the paint window. So here I'm going to type paint. And also I'm going to change the variable name. I'm going to replace frame with paint window, this one. Then again I'm going to duplicate this line, and this time I'm going to show the mask window. Here I'm going to type mask. And also I'm going to replace the window name, mask. And I'm going to set this file. Hey, before I run this code in my terminal, I want to say I'm going to use this pastel color bar as a tracker. As you can see, it's a blue color bar. And as you know, by default, we are going to select the blue color. So it's going to track this pointer. Now let's jump into the computer screen. So again, I am back to my Visual Studio code editor. And I'm going to run this code in my terminal. So I'm going to hit the run button. After hit the run button, as you can see, at first it show the color detector window. From here, using this slider, you can target any color. And as you know, by default we target the blue color. And we need to wait for some time to start the webcam. Now you can see here it opened total 3 windows: live window, paint window and mask window. And I'm going to align these windows side by side. And now I'm going to start drawing. Here I already grab a blue marker pointer and I hide it between my finger. And now I'm going to start drawing using it. As you can see, our camera track our marker and draw a line. It start drawing with blue color. And you can see the drawing in our live drawing window. Also you can see the same drawing in our white paint window. And in our mask window you can see the binary mask. And in our mask window you can notice it only track the blue color marker. It do not track anything else from this footage. And now I'm going to hide this marker and start drawing from the different point. And I'm going to start drawing from that position. You can notice again it start drawing the path from this position. At that way you can draw different line at different position. Now let me show you how can we change color. How can we change color of this stroke line? For that we need to move our pointer to the color button. At first I'm going to move this pointer at green color button. And now it select the green color. And if I start drawing, now you can see it draw the line with green colors. At the same way, if you want to change the color, just you need to put your marker to the next color. For now I'm going to select red color. Now it's going to start drawing stroke line with red color. At the same way, you can select yellow color. Just you need to hover your pointer above the yellow button. Then you can start drawing using yellow color line. This is how you can change color one by one. And if you want to clear this window, just you need to move your marker above the clear button. As you can see, after move this marker above the clear button, it clear the window. Then again you can start drawing in this canvas. So we successfully build our air drawing project. And if you want to close this project, just you need to press small q. It's going to close the windows.